Hello, class. So I wanted to give you an example on how to calculate tolerances. So tolerances are a little interesting. Tolerances allow us as people that construct things or repair things to understand what is the maximum and minimum dimension, what is the ideal dimension, and what is the maximum and minimum that we could be from that particular dimension. So for instance, in this particular dimension, I've got 0.5 plus 1.25 plus or minus, that's what this says. This is plus or minus. Let me write that here. This is plus or minus, that's how we would say that, plus or minus 0.0125. Now we talked a little bit about these common decimals already. This 0.5 is half an inch, and 0.125, that's a little trickier, that's 1/8 of an inch. So we're saying our ideal dimension would be half an inch, but we could be plus or minus 1/8 of an inch and be okay. So how do we calculate what our max and min are? That's what our goal is here. So we want to find our max value, what's our max value, and what's our min value. So our max dimension we'll get from taking our ideal dimension and then adding the tolerance. So that's our first one. So our first one is going to be 0.5 plus 0.125. And our second dimension, our small dimension, is going to be 0.05 minus 0.25. So we're going to calculate those two separately. So let's do our max dimension first, because I think addition's often easier. I'm going to line this up here. Now I could think of this as thou, and I could say I've got 5, and I would add 2 zeros here. I would have 500 thou plus 125. That's probably the easiest way. I could say together that's 625 thou, or 0.625. Now, if you're having trouble keeping up, that's okay. The other way to do this is to add these together by lining them up. So I could take this and I could say 0.05 plus 0.125, and then I would add some zeros here. So I'm going to add 2 zeros. Let's add those 2 zeros here. These are trailing zeros, so these are not affecting our answer. Add those 2 zeros. And then I add this coming down. So 0 plus 5 gives me 5. I've got 0 plus 2, that's 2. 5 plus 1 is 6. So this is 0.625 inches. That's going to be our maximum dimension, right? And be within spec. Let's do the minimum now. The minimum, we're going to subtract. So when we do that subtraction, we'll do this in green. So we've got 0.5 minus 0.25. So let's find our minimum dimension. 0.05 minus, and I want to line up those decimals, 125. Now I've got these here, and I need to add 2 decimal places here. And then I'm going to subtract. Now this is where I'm going to have to borrow. Now I'm going to have to borrow all the way from 5 because I can't borrow from 0. So this becomes 4. This is going to become 10, right? When we borrow, this becomes 10. And I'll borrow once more to make this 9 and 10 here. Now you do that. Now we got 10 minus 5. That's going to be 5. I've got 9 minus 2. That's going to be 7. And 4 minus 1 gives me 375. I'll put a decimal right there. And that's going to be 0.375. And I want to make sure I put dimensions on this. Both of these are in inches, so I'll put those units in there. Now, one thing you could do if you wanted to work backwards is I could go, okay, going this way, I want to add. I've got 5. I want to get to 10. I've got 5 plus 5 gets me to 10. Carry the 1, so this becomes 2 plus 1 is 3. 3 plus what gets me to 10? 3 plus 7 gets me to 10. So now I'm at 0 again, but it's 10, so this becomes 2. 2 plus what gets me to 5? 2 plus 3 gets me to 5. So you can work backwards using addition to help you solve that one. Let's move on and practice with this little bit harder one here. We've got 0.375 plus or minus 0.625 inches. So in both of these cases, we're working with what would be pretty common dimensions, very common fractions here. 3.375, well, this is something we see often. This is 3/8. If you're a woodworker, 3/8 plywood is a very common thickness used for house construction. So I see that a lot. And this one here looks a lot like 1/8, but it's not because the decimal place is a little bit off. This is not 5/8. This is actually going to be a 16th. That's half of 1/8. This is a 16th. So we've got 3/8 plus or minus a 16th. This would be pretty common dimensioning for lumber. All right, so if we're working with these dimensions here, let's first calculate our maximum, and then we're going to come find our min. So to find our maximum, remember we're adding here. So we're going to add these up. So we'll do 0.375 plus 0.0625. And I'll need to add a 0 in here. Need to add a 0 in here. Then we'll add these up. 0 plus 5 gets me 5. 5 plus 2 gets me 7. 7 plus 6 is a weird one. 6 plus 6 is 12, so I know 7 plus 6 is one more. That's going to be 13. And I've got 1 and 3. That's going to be 4. I'm going to put that in as 0.4375. And that came from adding these two. So this is our maximum. I'm forgetting something pretty important here. That's right, I need inches. Right, I need the dimension here. So that's our maximum dimension for this. Let's figure out what our minimum is. Now our minimum we're going to get by subtracting. So let's set it up similar to this. We're going to have 0.375. This is our minimum. But in this case, we're going to subtract 0.625. All right, once we've got that set up, I like to add a 0 in here. That helps me mentally when I subtract. In this case, I'm going to work the practice the adding that we worked on before. So, right, one way to do subtraction is to figure out what we need to add up to get to our top number here. So what I'm going to do is I've got 5. I need to get to 10 here because there's a 0. So I'm going to add 5. 5 plus 5 gives me 10. I'm going to carry a 1. This becomes 2 plus 1 is 3. 3 plus what gets me to 5? Yep, that's 2. And then I've got 6 plus something gets me to 7. I know that's going to be 1. So I can say, okay, this is going to be 0.3125. Or I could say, hey, our minimum dimension is 0.3125 inches. That's going to be our minimum. So now I have a range of values. I have my max and my min. If I wanted to write this as a range, I could say the dimension could be anywhere between 0.3125 and 0.4375 inches. If I have a dimension somewhere between those two values, I know that I'm in spec. And that's how we're going to find our tolerances. If we want to convert these tolerances into a range, you find your max and your min by adding and subtracting, and then writing it as a range like this.